Hello, I'm going to show you the glbp output. I'm using two software which are linked together. One is GNS, that is Graphical Network Simulator 3, and the other one is Virtual Personal Computer System software, that is VPCS. So this is the network topology that I have designed, and I have shown 4 routers in a circle, and this implies that I'm implementing the glbp protocol, the gateway load balancing protocol, in these 4 routers. The gateway load balancing protocol aims to reduce the traffic and manage the load from the layer 2 between the layer 2 and layer 3 interfaces, that is between the switch and the router. So I'm going to implement glbp at this particular interfaces, the first interface which faces the switch, and I have used the enhanced interior gateway routing protocol, which is simply called as EIGRP, to converge my network. Network convergence is a very important concept in networking projects, and I use EIGRP. So I'm going to show you with the help of ping command. So these are the networks that I have IP addresses that I have given to the routers that I have used in my program, and since I am at R1, router 1, I'm going to ping. This is the command which I'm using for transferring data from one router to another router, and I'm pinging with 60.0.0.1. Now the 60.0.0.1 is the address of my 6th router, so I am pinging from my data from R1 to R6. So you can see the success rate is 100%, and this is the average round trip time I've got. This is the minimum, this is the maximum round trip time, and so this 172 is the average round trip time that I've got. So but this is not the output of glbp, this is basically the output of EIGRP. So in order to show you the output of glbp, I will require you to show the output from C1 to C4 from my clouds. Inside of network doesn't count, the output from my clouds will count. So I'm now going to transmit my data from C1 to C4, and for that I need VPCS. I have already defined my IP addresses for my clouds. So since you can see here, the 10.0.0.50 is my VPCS 1, 10.51 is my VPCS 2, and my host 3, the cloud 3, is going to be 60.50, and my host 4 is going to be 60.51. So I have already transmitted my data. As you can see, I am in the first system, that is which has the address of 10.0.0.50, and I am pinging to 68, that is 60.0.0.51, that is from C1 to C4, and I have got some random values of time here. So I'm going to find out the average round trip time, and I'm going to find out the latency with the help of that, and throughput ultimately with the help of latency. And with the help of latency and throughput, I'm going to show you that I'm going to show you that glbp is far more efficient than any other protocol, or even without glbp, the glbp is pretty much faster. And the advantage of glbp is that it makes the maximum use of network resources present, and it has an efficiency of 99%. And I'm going to show you a graph which we have formed by ourselves after taking many readings from the VPCS. So as you can see, this has 4 bars. One is no glbp, second one is RR, third one is W, fourth one is HD. RR is nothing but round robin, W is weighted, HD is host dependent. These 3 are nothing but load balancing mechanism present in the glbp protocol itself, and so we have created the graph based on values from VPCS for different load balancing mechanism, and finally we can conclude that round robin is the most efficient load balancing mechanism which is present in the glbp. So I have implemented glbp in R1, R2, R3, R4. The glbp can be implemented only at 4 routers at the one point of time, but there can be many other glbp groups which can be formed in a group of 4 networks, in a wide network, in a very big network. So that's all about glbp and its output. I hope to upload a bigger video in the future. Thanks for your time. Thanks for watching. Thank you.